Yay! We got sound, we got picture. I think we're pretty good to go. Sadly, we were missing out on the matrix effect that happened for a while there. That would have been a fun presentation, though. Hello. We're a couple of minutes behind schedule, so I'll try to make up for it. So before I even start today, I kind of just wanted to highlight a tweet I found quite recently. I won't read it out completely, but essentially, one of my students recently wrote a sentence that, began with, "in the late 1900s." So if that doesn't make you feel old, it really should, because nowadays you're actually born in the late 1900s, unless you're very young. And that actually kind of brings me into this as well. So my name is Alexander Thor. I work as a senior product manager at a company called Vislib, and we build an analytics solution called Astrato. I spent the last 15 years within software. Out of those 15, the last 10 within business intelligence. And that kind of makes you feel a little bit old, and especially when you're born in the late 1900s. That's kind of why I dress like a teenager, to pretend that I belong with a hip 20 tech crowd something. I'm not sure if it works, but so I'm not going to sit here and do a full kind of product pitch or product demo onto you guys. Instead, I want to talk a little bit about sort of the thought process that went into our minds as we were sitting down, in the year 2020 to build a new analytics solution, and sort of the trends that we're seeing in the market, sort of how we're seeing things shift. And as you get a little bit older as well, you kind of start, understanding history a little bit more. You like to look backwards instead of forwards, and so on and so forth. So that's kind of what we want to play on here today. My CEO tried up until the last minute to make me put some product slides in here. I managed to defend myself, so there are no product slides. There's no markety gibby chibi. You're going to get scared of all of that, right? So hopefully that makes sense. So today, we kind of want to look at a little bit of brief history of decision support systems. So anybody know what decision support systems is? That's business intelligence before marketing got a hold of it, right? So initially it was actually called business support systems, which is a much better name than business intelligence, because there's nothing intelligent about these systems. So we're going to look at a brief history of time. We're going to try to understand the present, and then I'll share a couple of ideas that we have about the future kind of moving forward. So, and to understand the future, you have to understand the past, in the quote of Carl Sagan. And what's interesting about history is that it usually kind of repeats itself. You have these repetition cycles in history that comes and goes over a few different, 10 or 15 years or so, especially within tech. But it's not only within tech. If you're into fashion or anything, you're going to notice on the runways that, the 90s are back, right? You have the future King of England on the end there. So if you haven't actually changed out your wardrobe since 1990s, congratulations, you're cool again, right? You're probably cool, but you're probably not modern. But repetition isn't always good, right? So hopefully we're not seeing this next year, but you never know. Britney's free again, so it might come back in fashion. But if we take this and kind of look at business intelligence and data warehousing in general, I usually like to backtrack a little bit and start at the beginning, right? So we had our mainframes, we had our really big computers. This is back in the late 70s, beginning of the 80s, and they were actually really good. They had scalable pricing, they had scalable compute, they had all of these things that we kind of take for granted these days. The bad part was that they were huge. They required an enormous amount of just square footage to get into your company, and they also were quite expensive. So I started digging around a little bit around mainframes in general, and I came upon this old article from Computer World back in 1984. This has no bearing on the presentation. I just kind of thought it was cool that back in 1984, you still had pie charts and line charts inside of your terminal when you terminaled into your mainframe. So 40 years ago, you could still do graphics on top of data. So graphics on top of data is not a new field in any way or shape or form, right? It's been around for the last 40 years. This was also the year that Teradata launched, their first, I think it was 1012 computer on top of IBM's mainframes. And what's really interesting about this is that if you zoom into the article a little bit, you'll actually see that it came with, down here, it came with roughly 496 megabytes worth of storage for every processor. So that was quite a lot at the time. And if you wanted a little bit more, you paid roughly $37 per megabyte. If you wanted another processor or another MIPS, then you would essentially look at 60,000 and so on and so forth. So these were fairly expensive systems, and thus they were very limited in use. Only the really big companies could actually use them. Then we fast forward a little bit. We're coming up until the 90s, late 90s, and we were sort of seeing the rise of the data warehousing movement. So we're now getting into centralized storage. Isn't anything new. The mainframe did all of that. You had all of the data in one place. The difference now is that you don't only have one system. Sort of the application systems is kind of multiplying. You get the internet. There's more data coming in. The world is just getting more networked, and you're also getting more competition in the business space. And you're buying new types of systems that you never bought before. You're buying CRM systems. You're maybe even buying, marketing systems. Those didn't exist before this, right? So the number of systems that are producing data is kind of growing. And the way of tackling this is to bring in sort of looking at the data warehouse again. How can we collate all of these central, the sources, bring them into one repository, massage the data a little bit so it makes sense to perform analysis on. Hence, data warehouses came about. And then we would invent things like OLAP cubes to be able to do, dimensional slicing and dicing and so on and so forth. So they built upon sort of the predecessor, which were the mainframes, and kind of looked at the present and adapted to that. And it worked really, really well for a couple of years. Then along sort of we get the surge of the analytical tools. And now we're actually up in sort of the 2000s, 2005, 2006-ish. Roughly about the same time as SAP acquired Business Objects, essentially. And then everything kind of went downhill from there. But, we had the ClickViews of the world. We had the Tableaus of the world. And there were probably 20 more vendors at the time, but these are probably the two that are still around. And they searched for, a very specific reason. Because, the data is growing all the time. We're buying more and more systems. We're loading all of this into our data warehouses. And usually back then, you bought data warehouses either from IBM, SAP, or Oracle. Those were kind of the big three. Microsoft was there as well. And they had the full stack. You did everything in there. You modeled, you transformed, you analyzed, and you computed and you storage, right? Then sort of the Qlik and the Tableaus came around because they offered something that had become a significant thing, the performance boost. Meaning that the data warehouses had so much data in them, they were very costly to scale back then because storage was expensive. You probably even had to go and buy a physical server to scale out your data warehouse. And then these, the tools that came around, and they were fast, they were usually in memory, so they would take a copy of your data that you spent so much time putting in the data warehouse, and they would take a copy of it and just dump it somewhere else, and then perform compute on top of that copy of the data. And that solved the performance issue, and the scalability issue, and so on and so forth. I still remember, and this is way back, we came into a telecommuting company in Sweden, and we were going to try to run a SQL query against the SAP R3 system. We ran one query, then the entire data warehouse crashed, and yeah, that was the end of that analytics project. But it also kind of provided faster speed to value because you could circumvent the data warehouse. The data warehouse wasn't really keeping up anymore. It could take 6 to 12 months to ingest data into the data warehouse, and at that point, your business requirement had probably changed, or the data had changed. So these tools were really good at taking data from multiple different sources, stitching them together, and then providing a dashboard for somebody. So within that dashboard, you had all of this business logic and all of this transformation logic, essentially applying business rules on top of that very tiny slice of data, but only there and nowhere else. So this worked really, really well for a while. And then the entire industry got a little bit confused for a couple of years. Hadoop kind of came onto the field. Now we're up until 2010, 2015 almost. And everybody overnight essentially decided they had a big data problem. Not a lot of people actually have a big data problem. If you look at sort of the original 3 V's, which is like volume, velocity, and variance. You might have 2 of them, or you might have 1 of them. Very few companies today actually have 3 of them. But overnight, apparently everybody had a big data problem. So all of the IT budgets were spent on, doing Hadoop. And what Hadoop did was that you could put any data in there, and it was really, really cheap to scale. You had cheap disk space, and you could put any type of data in there, and it was just amazing. The problem with just putting data somewhere is that it doesn't actually give you any return. So if you start thinking about data as a financial asset, all of the cost actually acquiring the data, maintaining the data, archiving the data, and all of those things actually racks up a little bit of cost. And if you're not actually using the data, it's basically a wasted asset on your balance sheet. And this was kind of what we saw a lot of the times on the large Hadoop projects. People were collecting a lot of data, massive amounts of data, storing it in Hadoop, and then doing nothing with it. Probably one happy data scientist were running something on top of it, but that usually was the end of the line. Fast forward a couple of years, and now people are doing a little bit more on top of that data. But the need for centralized data has kind of come back again. So if we're looking now again at sort of coming into the modern age, the idea of a data warehouse or the idea of a centralized storage of data, you call it a data warehouse or call it a data lake, the idea is not, the idea is still valid. The idea isn't faulty. So now we're actually kind of repeating history again, and we're coming back. And we're coming back for a few different reasons. And I think that it's pretty evident when you kind of walk around in here as well, that there's more consumers of data. 10, 15 years ago, you might have had a data warehouse and you had a business intelligence system reporting on top of that data warehouse. Maybe you had some legacy crystal reports as well, right? But that was probably it. These days, you can just walk around here and you see off-the-shelf machine learning algorithms. There's companies selling you artificial intelligence solutions. You probably don't have one BI solution anymore. You probably have 5. Because the marketing department didn't like clicks, so they bought Tableau. And the finance department didn't like Tableau, so they bought Domo. And so now you have more and more consumers of data all of the time, right? So the need for having a centralized way of looking at data becomes more and more evident again. Because if you kind of leave data in these sort of dead silos, it's dead data essentially, and you can't write it back and there's only one consumer of it. There's even more application systems these days, I would say. I mean, nowadays you probably don't have just one HR system. You probably have, you have a people management system, you have a retention system, you have something that will work with bonuses and so on and so forth. So we have even more data systems coming in these days than we had just 5, 10 years ago. And you no longer have to buy everything from one vendor. 10 years ago, you usually bought everything from IBM, or you bought everything from SAP, or you bought everything from Oracle. You got an enterprise license agreement in place, and everything was happy. And then 2 years later, you'd kind of looked, turned around and said, cool, where's all the fancy dashboards that we were promised? And they would say, yeah, they're still in production. They're coming in a couple of months. Now you can actually pick and choose. You can pick your storage vendor. I want to run Azure. I want to have Snowflake. I want to have, data robots for doing something. I want to have whatever ETL, or I'm still saying ETL. I should probably say ELT, I think, which is the new fancy word of saying it. Basically, that's the same thing. But, so you can pick and choose whatever vendor you want to work with. So this has, it's much lower barrier to entry these days. Any mom and pop shop can go and buy a data warehouse, even if they don't need it. It takes them 10 minutes to spin it up, and it costs virtually peanuts. And they're also incredibly easy to scale, and they're very, very cheap to scale these days. You drag a little slider and something happens something happens up here. And I won't talk too much about the cloud, because if we're on the subject of history repeating itself and so on and so forth, the cloud is basically just this. We just come full circle, right? You just slap a few different names on this. It's the Amazon mainframe, it's the Google mainframe, or it's the Microsoft mainframe. But we're back to the mainframe era where you offloaded things to somewhere else, essentially. That's kind of what it is. So I think we've somewhat established that history repeats itself. And if we're looking at if history is repeating itself, we have repeated on the infra side, we repeated on the storage side, we repeated on the compute side, where we've actually gotten really, really good infra tools that barely didn't even exist 10, 15 years ago. We're actually talking about data ops. Who was doing data ops 15 years ago? Almost nobody, right? And the tools have become insanely much better. Storage has become insanely much better. It's cheap, it's easy to scale, it's almost a commodity at this stage. Compute is becoming a commodity. You still pay for compute, and sometimes in some cases quite a lot, but usually it's correlated to value, and it's not too bad. But what's kind of going on with analytics then? So the interesting thing about analytics for me is that it hasn't really come full circle into the next kind of repetition cycle. The rest of the business has actually evolved and gone through kind of like the next step, or actually returned to previous concepts that was really, really good and could now be solved better because the technical challenges aren't there anymore. So what's going on with analytics? So a lot of the analytics tools today were built back in the era where they were solving problems for the past. When they sat down and built their tools, they said, yeah, we're building tools because we want to solve the performance problem of data warehouses. So we're taking data outside of the data warehouse. We don't have a performance problem in data warehouses anymore, at least if you're a semi-modern vendor. They're trying to kind of shorten the loop to value. because it took too long to model data and kind of get it into the data warehouse. Now, don't get me wrong, getting data into a data warehouse is still complex, and it takes time to model data. But these days, it doesn't take time because the tools are slow. It takes time because the business processes takes time, and it should take time. But at least the technical barrier to doing data modeling and sort of offloading data into your data warehouse has kind of gotten reduced quite a bit. So a lot of the previous analytics vendors actually were solving problems for the past that aren't really applicable anymore. And they were basing their entire software stack on problems that doesn't exist anymore. So instead, I want to talk about like what's the opportunity for the future. And this is what we identified when we kind of looked at our product. Our product, in a sense, isn't super unique. I think it's unique in the market space, but I think if you're a very savvy coder, you could probably build something similar yourself. So this is also something that I want to touch upon. And we built it around 3 core principles that, play the data where it lives. So don't take the data out of the data warehouse. And we still see this to this day, where people will kind of take the data out of the data warehouse because they want to ingest it in their business intelligence tool. And the problem with doing that is that it's so tempting to start transforming the data in the process. I'm just going to apply a little bit of formatting here, or I'm going to do a little bit of a calculation over here. And all of a sudden, you have a financial calculation or a financial metric that only really exists in your dashboard. And now your data scientist comes along and says, yeah, I really would like that number to incorporate it into my model. And now you're screwed, because that data just live in that dead dashboard and doesn't live anywhere else. So what we're trying to say is that, don't transform data for your dashboards. Push it back down the line, always pushing it back. So push back, transform, and even compute, in our case, onto the data warehouses. We do not want to have, silos of data inside of our business intelligence stack, which is modeling data and informing business logic that we can't move anywhere else. We're also talking about closing the analytics loop. And what we say with that is that at the end of the line, if we go back a couple of slides, so a lot of the times you kind of see the arrows kind of end here. This becomes sort of the end of the line on the subway station, in a sense. The data gets put inside of a dashboard, and that's the end of the story. Everybody's happy. Let's go home, essentially. And it doesn't really happen like that in real life. In real life, even if you're looking at a metric inside of a dashboard, something happens. Some decision is probably being made. Some discussions between colleagues are probably being produced. You might be able to leave a comment on the data. You might even want to supplement data and write that back to the source. So we think that it's highly important because these systems actually generate data points, but they usually don't write that back into the data warehouse, which they really should. So all of these things we think we should capture. So that's when we talk about sort of the analytics loop. So I kind of want to leave you with kind of looking at the investments that are being made today, which is highly sort of within the centralized storage and compute space. You can call it a data lake, you can call it a data warehouse, but at the end of the day, you're putting data somewhere. I could argue that in a couple of years, I think the boundaries of what a data warehouse and a data lake is just they're gonna be the same thing. Back in the days when we were doing data warehousing, you would take data out if you weren't analyzing it because of compute and performance issues. These days, you can freaking dump everything into these data warehouses, and they still perform and they still scale very well. And the problem of leaving data out is that you can never anticipate what type of questions your business users have. That was also sort of the inherent problem with the cubes, that if you did financial reporting, you'd probably find that doesn't change that often. But as soon as you wanted to travel outside of that dimensionality, you were kind of screwed. So closing the analytics loop, play the data where it lives. So don't move data around between different systems. Keep it where it are. And data is scaling as well. Data is just becoming bigger and bigger and bigger. And I think I had the unfortunate title of RIP in-memory computing or something along those lines on this talk. I will blame my marketing department for that one. But it makes sense. Data is growing, and if there's something that isn't growing, it's actually RAM. RAM isn't growing at the same speed as data. And if we're looking at the data or the cloud providers these days, RAM is actually the expensive resource these days. It's not storage. CPUs to some extent, but RAM is still the thing that will really cost you, right? So we can't read data into the memory, sort of the memory of computers anymore. And we don't have to, because we did that for performance reasons, and the performance is actually pretty good of just querying directly these days. So I kind of want to finish off, because I think we're getting up to the end here, and I'll take a couple of questions. is that the future is kind of already here, and this is usually the case. It's just not very evenly distributed. So what we're seeing here, and what you are probably seeing if you're walking around here or talking to your colleagues, you're probably in the forefront because you even show up at these kind of events. The rest, sort of the common man, usually see what we see a couple of years later. So we do think that the future is already here, and to understand sort of the past, we understand the present, and the future, we have to understand the present, and so on and so forth. We think that we saw, compute, storage, infra coming full circle. That will probably live now for quite a while until we sort of see a major shift in technology. But we're still waiting for analytics to come back again and do the next iteration of technology. So if this sounds anything that's interesting, and now comes the marketing pitch, you can come see us. We're at this booth. So the main entrance is over here. We're over here. So if you don't, like what you hear, you can just leave, right? And with that, I'll open up for some questions. And if there's no questions, I'm just going to dance. So, someone over there?
I have to keep hold of it, sorry, sir.
Okay. Yeah, I'd like to see you dance. No. So is the data supposed to be centralized, or should we leave it decentralized, or something in between? Where are we going? Because I heard in the morning they were speaking about decentralized data, and then there was the session afterwards about centralized data. So what are we supposed to believe in?
And I'm going to do the boring answer, which is kind of like, it depends, right? I think there's definitely a need for, depending on how you do analytics inside of your organization, I think the answer will depend. But if we're looking at the traditional type of business, I do think you should probably put it centralized. And that is for the sole reason, if you have your data in one place, it's easier to get to. So when you have that next question, you can get to that data point. Then it's not another project of, I need to ingest something else, or I bring it into another tool, or so on and so forth. If we can find like a really cool tool that can do like a semantic layer across data warehouses and data lakes, and can query it with sub-second response time, that's going to be a really cool product. So yeah. No more questions? Is that going to dance? Oh, okay. Then we'll close out the talk. Go have lunch, get some calories in yourself, have a coffee, and thank you.